Alright everybody, so sorry for the massive delay in another video being uploaded, but between my new job at the post office and actually getting sick here, I just had no energy, alright? I apologize for that. I still feel kind of rough right now. You may be able to tell in the video I'm just not myself. But I'm also learning a lot in my new job. So I've been tired. But I'm going to try and make something here at least as an in-between or something to, fill in the gap, give you at least something to look at. And in this video, we're going to talk about binary code and how to convert binary code into hexadecimal and to ASCII. Now, ASCII, by the way, is the American Standard Code for Information Interchange. Alright, we'll get into that a little bit more in just a second, alright? But the first thing, obviously, we're talking about binary. That's our main thing we're talking about, alright? So, when it comes to binary codes, alright? Binary is the language that's used by computers, or circuit boards, or processors, the CMOSes, etc., okay? Those are the zeros and ones that we see. Like, have you ever seen Futurama, and you had the episode where Bender went back in the past, and it was a binary code, like 01110000111111, so on and so forth? That's binary, okay? Now, in order for us, human beings, to understand the language being spoken between different types of computer languages or binary, we need to convert that to either one of two things, and that is either hexadecimal, which is a very basic 0 through 9 and A to F conversion, okay? So if you're ever looking at like codes coming out of a processor, and it says something like 2AFF or 2AF or anything of that nature, that's hexadecimal, okay? Hexadecimal has its limitations. You're only able to use numbers 0 through 9 and letters A through F in hexadecimal. But how do we create words and symbols using our binary sequences? Well, in order to do that, we need to use ASCII. Again, American Standard Code for Information Interchange. That's what ASCII stands for. Alright? That's where you're going to get your A through Z, upper and lowercase, and you'll get your different types of symbols like exclamation points, question marks, and so on and so forth. Okay? That's how we can do that. These are the two forms used in order to understand binary in the human language. And hexadecimal and ASCII can actually be converted into multiple different languages, and you can even make your own conversions using these two to create your own binary code, like sequences or codes out there to communicate with each other. So you don't necessarily have to follow this, not unless you're trying to actually figure out a circuit board issue for a standard game out there that's going to follow these two regular settings. You could go around and actually make your very own language up with hexadecimal and ASCII and convert that to binary and vice versa. So if you wanted to make a coded message to one of your friends, that's something you could do. Alright? But let's kind of move on and understand a little bit more about what all this is talking about. So to start out with, we're going to start with binary. Alright? Now, with binary, well, actually, I'm sorry. Let's step back a little bit. Let's look at the zeros and ones. Now, on this example here, you can see we have a 0010 01010. Alright? Now, as you can automatically tell, I screwed up and I added one too many numbers here. We don't need that 0 right there. Okay? So ignore that 0. Ignore my mistake. I did this while I was super sick, so I wasn't paying attention, obviously. But a single number, like the 0 or a 1, those are known as bits. Okay? Now, if you were to extend that into 8 bits, as you can see here, minus the screw up, that's known as a byte. Alright? So you have a gigabyte and a hexabyte and so on. This is what we're talking about. Okay? Bits are singular. Bytes are based off of 8 numbers in the binary string. Okay? Now, going from there, let's start talking more about binary to hexadecimal conversion. Now, binary to hexadecimal is a little bit different than binary to ASCII, alright? When you're talking hexadecimal, we're talking 4 bits, okay? So when you have a string of binary, like you can see right here, 0001, 0101, 0111, 1101, though that is obviously our binary code, but when we want to convert that to hexadecimal, we need to split this up into 4s, okay? Because hexadecimal is only talking about 4 bits of data at a time. And if you see in this example, 0001 actually equals 1. 0101 equals 5, 0111 equals 7, 1101 equals D. So that means that our outputted hexadecimal, converted from the binary code that's coming out, creates 157D. Alright? This will make a little more sense later on in the video when I start showing you some of the hexadecimal and ASCII conversion tables, okay? The reason why this is important, for example, if you're using a software program where you can test processors and you're sending bits of information to other parts of the circuit board and you want them to read that information back to you, let's say you put in this exact code right here, or basically 157D, you should be getting this code right back to you. So if you put this info in, and instead of getting 157D, you got 158C, you can tell that there is a problem in one of your binary strings. And then you can break the binary string down to see where that problem's happening, and kind of be able to make a decision off of that on where you may have to make a repair of some kind, okay? Now, going on from there, we're going to be talking about ASCII, which is right here. ASCII is using bytes, and as you can remember before, up here, a byte is 8 bits. So when you have your binary string, like this one here, 01001000, 01101001, we have to split that up in 8s. So here are 8 bits split and another 8 bits. And when you look on the ASCII conversion tables, this 8 bits here converts to the letter H, the uppercase H, and this 8 bits here converts to the lowercase I, creating the word hi. Alright? Now you notice here, 072 and 105, those are the actual code numbers associated with the ASCII coding. And you're going to see that here in a moment when I show you the actual charts, okay? Now, just to make things a little simple, I'm going to keep this page out so you can kind of see it while we look at this, which is the binary to hexadecimal conversion chart, okay? So, when we look at the binary to hexadecimal, if you have zeros all the way across the board for our 4 bits, that creates 0. Well, if you have 1s all the way across the board, that creates the letter F, or the decimal 15. They're interchangeable, and it kind of depends on what you're testing. So you need to remember that too, that you might not get the letters like A through F. You might get numbers, and you got to still correspond the binary sequence with those decimal numbers. Most of the time, you're going to be dealing with the hex side of it, so 0 through F. And if we look here, that's where we get this information here. So 0001, right there, creates 1. 0101, right there, creates 5. And then 0111, as there, 7. And 1101, right there, creates D. And that's where we get the 157D, okay? That's how we kind of do our conversion. So, if you take your binary sequence and split it up into 4 bits, and then take these bits and compare it to the binary to hexadecimal chart, you'll see what it corresponds to, and you can make your resolution or your sum or whatever you want to call it into what your output code should be in our English language, okay? Now going off of that, we're now looking at the ASCII binary character table. This is the uppercase, and we have a lowercase, okay? So as you can see, we have A all the way down to Z. And then here's that ASCII code I was talking about. Because remember, if you look here, that's 072. 072 creates a capital H. And the code for that is 0, or the binary is 01001000. Right there. And the same goes when it comes to lowercase. There's a whole separate code sheet when it comes to the lowercase letters. As we talked about before, the lowercase I is an ASCII code of 105, and if we look here, 105 is the lowercase I, 01101001, and that binary string matches up. So if you're trying to convert your binary codes to ASCII language, remember, you have to use 8 bits. Then you just take these bits and you compare them to your ASCII binary character table and find your code number. Once you find your code number, you know the letter. Of course, you can go off of the binary itself if you want to, but there's a faster way to figure this out, and that's literally using the ASCII code number. And I'm going to show you how you find your ASCII code numbers out, okay? So, what we're going to look at next is the actual method used in order to figure out how to convert ASCII from binary, alright? And it's a little bit of math involved with this, but it's simple math. The most basic math you can think about, okay? So, let's start out with our binary sequence. And in this example, our binary sequence is 0111, 0111, okay? Now, what has to happen is we have the powers table, alright? In binary, we're talking about the powers of 2. And that also corresponds with ASCII. Because in binary, you only have 2 numbers to choose from. You have a 0 or a 1. So the power of 2. Okay? You remember, since we're converting binary into ASCII, we have to go off of 8 bits. So because of that, we're going to be using exponents in that format. So the next line we're going to look at is just that. We are by the power of 2, and we have 8 bits. I know this says 7, but we have a 0 here. So when you add that all together, we have 8 total bits. Okay? Now, The standard English language in ASCII has 128 characters, and that's a combination of uppercase, lowercase, and then symbols. And again, symbols are like exclamation points, question marks, and so on. Okay? So what we have to do is have our decimal values, which is what those are. So our decimal values are going to be 128, 64, 32, 16, 8, 4, 2, and 1. Alright? Because remember, like I just said, we have 128 symbols within our ASCII coding. Because we have uppercase letters, lowercase letters, and symbols themselves, like exclamation points and so on. Now, since it's being done by the power of 2, we're dividing each of these down, as you can tell, because half of 128 is 64, and 32, 16, 8, 4, 2, and 1. Just like that. So this is our basic standard setup right here. This is the equation you're going to start with when you're trying to convert your binary code into ASCII. Alright? Now what's going to happen is we need to multiply. As you can see here, we need to multiply our decimal values by our binary code. Okay? And as you can see right below here, I have our binary code. 0111, 0111. Okay? Now when you multiply each one by the binary, so you're going to do 128 multiplied by 0, 64 multiplied by 1, and so on, you're going to create an answer from that. And when we look at it, we get 0, 64, 32, 16, 0, 4, 2, and 1. And you'll take all of these numbers that you get from multiplying each of the decimal values to the binary code sequence, and you're going to add them all together. So with this specific one here, we already know 128 times 0 equals 0. Okay? 64 times 1 equals 64, and so on. Okay? That's pretty simple, right? Then we're going to add this all together. Ignore the zeros, because obviously they're adding nothing. So it's 64 plus 32 plus 16 plus 4 plus 2 plus 1, and that equals 119. Alright? So, if you take that 119, as you can see, we have a W here. We look at our ASCII conversion table, and 119 for the ASCII code is a lowercase w. So that's how we can tell that 0111, 0111 actually converts to the lowercase letter w. Okay? That's how you'll convert your binary into ASCII. I know it might sound kind of confusing, but when you start doing it a little bit, it makes a lot... It's easy. It's not as hard as you think it is. You just need to set your equation up properly. Remember, you have your 8 bits, 2 to the power of 7, all the way down to 2 to the power of 0. And then you have your decimal values, because remember, we're talking about 128 characters in total, and since it's being brought to the power of 2, we're going to divide them by 2 all the way down the string. And then you'll multiply your decimal values by your actual binary string. And then you'll take all your answers from that multiplication and add them together. And whatever you get, and you take that number and look at your ASCII code conversion, you'll find what letter or symbol it represents. And I'll be 100% honest with you here. I have not looked up or written down any of the ASCII codes or binary sequences that work for the symbols, like exclamation points, quotations, and so on. I only did letters. I want to try and keep it as simple as possible, even though it sounds very confusing. So what we're going to do here is we're going to go ahead and do a little bit of a, a test. We'll try it out. I'll show you how we go about doing this in real life, okay? The first thing I want to do is I want to make sure that I have my ASCII conversion tables at the ready. Alright? Alright, so we have our character table set to the side for ASCII. Now remember, we want 8 bits in our sequences for ASCII conversion. So, 1, 2, 3, 4, 5, 6, 7, 8. Just like that. And we're going to do the same here. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. And continue on from there. Okay? Alright, so now we have our 8 bits for each little binary sequence. And these are the 8 bits we need in order to convert it into an ASCII code language that we people can actually understand. So, using our formula before, we're going to put our first 8 bits of binary sequence below this and do the math. So our first 8 bits is 0, 1, 0, 1, 0, 0, 1, 1. So we have 0, 1, 0, 1, 0, 0, 1, 1. And remember, we're multiplying these, okay? So, when you think about that, 128 times 0 is 0. 64 times 1 is 64. 32 and 0 is 0. 16 and 1 is 1. Or 16 and 1 is 16. Then we got 0, 0, 2, 1. Okay? So, what we're going to do from here is we're going to take 64 plus 16 plus 2 plus 1. Okay? Now, when you add 64 plus 16 plus 2 plus 1, you're going to get 83. Okay? Now, when we look at our conversion tables, let's look for 83, and there is 83 right there. It is a uppercase S. So, that's what that creates, okay? Alright, so now using our second 8 bits of binary, we have 0, 1, 1, 1, 0, 1, 0, 1. And using our multiplication, we have 0 plus 64 plus 32 plus 16 plus 0 plus 4 plus 0 plus 1. Now, when you go ahead and add 64 plus 32 plus 16 plus 4 plus 1, you're going to get 117. Okay? Now, when we look at our binary setup, 117 is the letter U, the lowercase letter U, okay? That's how you'll do that. And I'm going to continue this same process with the rest of these, alright? Let's go ahead and see if we can't just do it real fast or do at least one more together, okay? The next one is going to be 0, 1, 1, 0, 0, 0, 1, 0. Now we have a 0 plus 64 plus 32 plus 0 plus 0 plus 0 plus 2 plus 0. So 64 plus 32 plus 2 is going to come out to 98. Okay? 98. And when we look at our conversion, 98 creates the letter B. Lowercase b. Alright? So, now knowing that, I can continue on in the same pattern by following the rest of these binary strings that I have set up as 8 bits. Alright? Now, I'm not going to go through the whole thing, but I'll tell you right now that this whole binary sequence you see right here creates the word S, U, B, S, C, R, I, B, E. I know it's, but definitely subscribe to the channel, okay? It helps me out a lot. I would have gone through the entire sequence, but come on, it's all the same. It's just basic math. Do some multiplication like I showed you here, and do a little bit of addition, and then compare your final number to your ASCII conversion, then you get your letters, okay? So go ahead and give it a try, do some practice. Anybody can do this, so give it a try. Thanks for watching, and I'll see you on the next video, guys. Take care.